So right now we're gonna be looking at lesson 1, which is exponential functions. So we just reviewed the exponents, some exponent laws, and how to evaluate some of the exponents. So let's just take a look at this one here. What is an exponential function? So an exponential function is any function that can be written in the form y equals to a to the power of x. The exponent here is a variable x, where a is a positive constant. Okay. So a is our base and it's a positive constant. So here. So a is our base, x is our exponent. Okay. Now, from the first two activities, initial activities that we did, we graphed a similar function. We graphed y equals to 2x earlier. This one is a to the x. But here, a is greater than 1. So anything that's greater than 1. What does that look like? It's going to look like this. Okay, so what are the characteristics of that? So just looking at this one here, if the base is greater than 1. If we have something like that, an exponential function with the base greater than 1, the function is going to be increasing. It's going to increase to the right. Okay, that's what it means, it's increasing. The graph has y-intercept of 1, and we saw that too. So y-intercept is here, it's 0, 1. What's the other characteristic? The graph approaches the x-axis but never reaches it, so it has a horizontal asymptote at y equals to 0. So this is our horizontal asymptote.
I'll see, I'm going to move to the library. I can't do it.
Okay. The graph has no x-intercept because it just gets closer and closer and closer to the x-axis. There's no x-intercept here. And then the domain is negative infinity to positive infinity. And the range is from 0 to infinity. Now, for graph number 2. The graph of y equals to ax, and that has to be, this one has to be changed a little bit. So can we change this to, the a has to be between 0 and 1. So a is still a positive value. A is still positive value, but it has to be between 0 and 1. Okay, so let's make that adjustment right there. And we've seen it before. In this graph, the graph is decreasing. It's falling to the right. As x gets bigger and bigger, the value of the function gets smaller and smaller. The y-intercept is 1. We've seen that. The graph approaches the x-axis. Again, the asymptote is 0. Y equals to 0. So that means there's no x-intercept, the domain is from negative infinity to positive infinity, and then the range is from 0 to infinity. So we can say x is an element of real numbers, or we can say y is greater than 0. Okay. Now let's get into something like this. Let's take a look at example number 1. It says sketch the following exponential function. We're going to sketch this, and let's see. It says here y equals to 3x. The word sketch. Okay. Now, the word sketch is we're not going to do every single point, every single thing. I'm going to show you something. I'm going to put this to you. Maybe one for food and one for Jake in the back. The others are not quite. Okay. So I just want to show you this because in a provincial exam, that's okay. No, it's okay. Thank you. In the provincial exam, you're going to see something like this, and it's just some keywords. When they say sketch the graph, we're not going to do like point by point, every single point match, right? But we're just going to provide a detailed drawing with key features, key characteristics of the graph that includes a minimum of 2 coordinate points. So if we can specifically show a coordinate point or 2 coordinate points, that would be great. So it says here y equals to 3x. Now, what are the key points that we can do? Well, we know if x is 0, then our y is, these are points, x and y. So if x is 0, y is 1. So this is 0, this is 1. That's one point. Now, the other point that we're going to take a look at, well, what if x is 1? What if x is 1? That's going to give us 3. So 1, 3. Now, we got 2 points. Can we graph this with just 2 points? Can we figure out what's happening in here? It's an exponential function. So far, we got 2 points here. How does the graph look? Okay, is it just going to go this way? You'll notice that if you have a simple function like this is a base function, y equals to 3 to the x. If x is 0, y is 1. If x is 1, the y is your base value. Right? If x is 1, your y is your base value. So is the function increasing or decreasing? Now, just by looking at that, is that going to be increasing without graphing? Is there a way for us to figure that out, that it's increasing? It's going to be increasing, right? And just by looking at the graph, just by looking at the function, the equation in here, how do we know if it's increasing? Because of the 3, okay? Because base is greater than 1. If anything, if the base is greater than 1, then the exponential function will increase. Intercepts. So x-intercept, none. But y-intercept equals to 1. Equation of the asymptote, y is equals to 0. So our asymptote is here. Domain is from negative infinity to positive infinity, and range is from 0 to infinity. Is that good? Let's take a look at the letter B. What do you think this is? Is this going to be an increasing exponential function or decreasing? And then explain why. This one's going to be decreasing because base is between 0 and 1. Between 0 and 1. That's why it's decreasing. The x-intercept, there's none. But y-intercept, that's when x is 0, it's 1. Equation of asymptote, y is equals to 0. Domain is from negative infinity to positive infinity. And range is from 0 to infinity. So how can we graph this with some points in here? So we'll start with the y-intercept is at 0, 0, 1. It's 1. And then if x is 1, your y is the base value, 1/2. And then from here you can so you've got this 0, 1. And then this other point would be 1 and the base is 1/2. Let's show our asymptote here. Is that okay? Good. Okay. Take a look at this one. This one's a little weird. The number e frequently occurs in mathematical, especially in calculus. So now it's like showing the significance of this e value. And it's an irrational number like pi. So it's an irrational number. And the value for e is 2.718 approximately. Okay. So if you actually take out your calculator, so if you take a look at the calculator, you might see the e in there and you're wondering, what is e? So if you look at your calculator, this is my calculator here, you might see the e. I have my e to the x in here. So I don't have just an e button, just e to the x. And if I press that, it would be 2.718. Okay. Did you see e in your calculator? So 2.7. Okay. Now let's take a look. So if is the function increasing or decreasing? What do you think that is? Is that going to be increasing or decreasing? Is there a way for us to figure that out by looking at the function? So this is really approximately y equals to 2.718 to the power of x. So is that increasing? Yeah. So it's increasing. We have to state why, because base is greater than 1. Intercepts. So x-intercept, there's none. Y-intercept. Y-intercept, that's the value of y when x is 1. Sorry, when x is 0, it's 1. The equation of the asymptote, that's y equals to 0. The mean is from negative infinity to positive infinity. Range is from 0 to infinity. Okay. Is that good? Now this one here. Any idea on how we can graph that? Because that's a little bit different from what we've been doing in the past few minutes. Y equals to 2 to the power of x. So without this part here, y equals to 2 to the x, that's our exponential function. Now there's a plus 3. What do you think that plus 3 is about? Give you a hint. What kind of transformation would that be? Up 3 units, right? So that means this is your function, and then it's going to be shifted up 3 units. Okay, now let's start with this one here. Is the function increasing or decreasing? Okay. The base is 2. Okay, so it's going to be increasing because base is greater than 1. Now y-intercepts. Now let's see first, before we get into this one here. Initially our asymptote, I'm going to jump to number 3. Initially our asymptote was here, right? At y equals to 0. But because everything is shifted up, that also includes our asymptote. So our asymptote now has been shifted up 3. So 1, 2, 3. Asymptote is right there. Now earlier we have a point 0, 1, but now every point is shifted up 3 units. Now it's going to be 0, 4. 1, 2, 3, 4. Okay. And initially, our graph would be 1, 2. This is our initial graph. It's our initial graph, base graph, but it shifted up 3. So 1, 2, 3. So your graph looks like this. This is going to be 1, 4. This is going to be 0, 0, 4. And then this is 2, 1, 2, 3, 1, 5. Because everything is shifted up 5. Shifted up 3, so now it's 5. Now intercepts, x-intercept, still none. But y-intercept now is at 4. Equation of asymptote, y is equals to 3. The domain is from negative infinity to positive infinity. Now what about the range? The range is now going to be from 3 to infinity, not including 3. Okay, so this one is just one transformation. And I'm actually just going to review our transformation here in a second, because it's been a while since we did transformation. We said in terms of transformation, you might be able to write it on here or on a separate sheet of paper. If you have room, you can do it here. So y is equals to a f of b times x minus c plus d. Right? I think some texts it would have the h and then the k. H is a horizontal, k is a vertical translation. So the A tells us what? The A tells us that it's going to be vertically stretched or compressed. It also tells us if it's vertically reflected. So A tells us vertical stretch or compression, or vertically reflected. The B, that's the horizontal stretch or compression. And if it's a negative, it's also going to be a horizontal reflection. So this is going to be always x minus c. Minus c. That's going to be horizontal shift. You're either shifting to the right or to the left. And then d, that's our vertical shift. Up or down. Now, just to remind ourselves again, when we look at the critical points, so we have x and y are points, and then if we were to do a mapping mapping, we said that's going to be x over b plus c, right? So after the transformation that happened in here, it's going to be x over b plus c. That's your new x coordinate, and then your new y coordinate would be a y plus d. So in this case, in this particular case, our original point was at 0, 1. The b is 1, the c is 0, so the same thing as 0. And then a times y, the a is still 1, the d is 3, so it's going to be 4, so 0, 4. That's why we got 0, 4 there. The other point that we have was 1, comma 2. 1 and then the base. 1 and the base. So it's 1, comma 3 plus 2 is 5. So 1, comma 5. So it's 1, comma 5 right there. Okay. So, are there any questions about that piece? Yeah, yeah. Right here? If you're gonna do the mapping, you could do it all at once. Then you could have this point after it's been transformed. It should really, this is your new point. This is your original point. Your new point from based on the transformation, it will be 1, 5. So you can do it all at once in here. Yeah, through mapping. Okay. So far so good. Okay, I think I'm gonna stop right here. Okay, so I'm gonna stop right there. So I'm gonna assign some questions, and then, like I said, these are baby steps. It's important that we try them. Just don't take them for granted. So these are the ones that I'm gonna assign to you, and certainly you can do them right now until the end of the class. So please do the following questions. So practice question. On page 349. Okay, I'm going to do question number 3. Question number 6, and then question number 7. So question number 3, 6, and 7. Now if you take a look at question number 6, it says on your book, use graphing technology. You actually don't need graphing technology, right? Just to show what question I'm talking about here. Right here. So it says here, use technology. No, we don't need that, because we're just gonna sketch the graph, right? We have strategies for that. So sketch the graph. I have some graph paper at the front for you to work, for you to use, and then identify some important characteristics of that. That's about it. Okay, so give those questions a try. Highly, highly recommend them.